Well, welcome back. We are in the most challenging projectile problem that you will see, and I won't even give you one like this on the test there. Oh man, you only get that information if you actually watch this film. That's awesome. Okay, anyways, let's go ahead and let's go through this. I'm assuming that you've done 1, 2, and 3, so I'll go a lot faster than those other ones there. If you need more explanation, go look at those other ones. It's the same thing, just a slightly harder case. So you watch that YouTube video clip because you just paused this thing. They slide down a 200-foot water slide, and it takes off at an angle 30 degrees above, so it looks kind of like the last problem right there. Something like that. That's probably steeper than a 30 degree, but yeah, that's okay. We know that the velocity here is going to look like this. This is my original velocity, and we don't know what that is. Huh, interesting. And then we'll go, okay, well, whatever it is, there would be component vectors for that, so I'll just do all of the things that normally do help me. And all right, so now I'm not going to label exactly what these sides are, but I'll put in everything I do know, like this is in 30 degrees going on there, and I know what I would label these would be like V naught cosine 30 and V naught sine 30. And well, maybe I'll go and do that because we got to solve for that, and we probably were actually going to use the V naught cosine 30 or V naught sine 30 to go and solve for that. So I'll write it like that, and I can always change that later. He lands 31 meters away. How fast will he be going when he takes off? And he's, again, 4 meters above. So it's similar to actually the last problem here. I need to put the ground in here. Let's put the ground in. And from here to here, here's 4 meters. It's from there to there. We're going to set the ground to be my 0 position there. And so that means y naught here, the original position for them at time 0, is going to be 4 meters. So I'm kind of reminding myself of that. They're going to land somewhere over here, so we'll draw the path in. And they land, let's say, right there. And so now that is an ending position there of 0 meters. What else do we know? We know that gravity is pulling them down. We'll call that a force of gravity. When that causes some acceleration, we know what that acceleration is. It's negative 9.8. And we recall that that's in the vertical dimension, not in the horizontal dimension. Great. And he lands 31 meters away, so we can put that there as well. There to there. 31 meters. And if I need to, I also label these things as a variable there, although you've probably gotten used to that thus far. Maybe not. I don't know. Doesn't matter. Anyways, we're going to separate this into x and y charts here. We know that the x dimension is going to be separate from the y dimension calculations there. I seem to there's always more going on in the y dimension usually, so I offset that a little bit. I don't make it exactly even. It seems to help things out. I look in the x dimension, and it doesn't matter. You could start looking in the y dimension. I don't know why I always keep starting in the x dimension though, but I do. So I go there and I put in what I do know. Do I know the acceleration? No. Well, I mean, yes, I do, but it's 0. Acceleration in the horizontal dimension is 0. And so then my V naught, well, my V naught is V naught times the cosine of 30 degrees, then multiplied by some t. And, and I do know that that's 31 meters. Cool. We're trying to solve for V naught, so maybe I'll actually go and solve for V naught if I can find the time that it takes to go down there. And I'm thinking about that and going, oh, the time to go down there, that's going to be difficult if I don't know both the V naught and the time, but yeah, we'll figure it out. So don't get up in arms when you're like, I've never seen a problem like this before. You know what? It'll probably work out. Everything will work out in life. Don't you worry. Don't you worry. Do the birds worry about what they're going to eat now? Some of them die, though, I guess. Anyways, that's a little bit morbid. Sorry. Anyways, 1/2 at squared plus v naught t. I look at this and I go, hey, I know the acceleration. Great. I'll put that as like I know that one, 9.8. The original velocity, well, I kind of know that. I don't really know it. It's v naught sine of 30 degrees. I know that. And then I don't know the time. I do know the delta y, and the delta y is going to be negative 4 meters, just like in the last problem. I'll go ahead and do that. I'll show that, though, that the ending, gosh, if I can erase that, there we go. The ending position is 0, the beginning position is 4, so that means it's going to be negative 4 for that thing right there. So I move that equal sign down a little bit more. Let's go ahead and put these in and see what we get. We get negative 4 is equal to 1/2 times 9.8, or negative 9.8 is negative 4.9 t squared, plus v naught sine of 30 degrees multiplied by t. Okay, cool. So now, can I solve this? Well, no, I can't, because I have two variables that I don't know, v naught and t. And over here I got v naught and t. But then, wait, hold on. But then I look at that again and go, wait, I can't solve this equation. Why? There's two variables I don't know, v naught and t. I don't know either one of these. Oh, okay. And then I look at the same one over here, and I go, I can't solve that. Why not? Because I don't know v naught, and I don't know t. And then I recall to myself, wait, hold on. I have two variables that I don't know in the left equation, two variables I don't know in the right equation, and they're the same variables. Wait, this is digging up math class for me before. And I'm recalling, slash you're recalling, that's why I'm stalling here, is that if I have two equations and two unknowns, and they're the same unknowns, I can solve that. Math says that this is a solvable thing right now. So I got to choose. Am I going to solve? I'm probably going to do substitution. Elimination would probably be a headache here. So I'm going to use substitution to solve for this thing. Now I'm asking. Now it doesn't matter whether I solve for t or I solve for v naught. So I'm thinking to myself, what would happen if I do one way or the other? And if I solve for v naught, I only have to put it in one, and I'm going to solve for the left equation and put it into the right equation, merely because the left equation is way easier and simpler, and the right equation is degree 2 polynomial, so it's probably going to be easier to plug a simple thing into that one. Now, if I solve for v naught, I only have to put it in one place, and so then this thing gets bigger. And so and I'm doing this in my head, but I'll write it out for you. I'm going to go ahead and solve for. I'm going to drop the units on it as well to simplify this. I'm going to solve for v naught just to see what it looks like. So I'll put t on the other side, and I got to get cosine of 30 away from that thing as well. And so here's v naught. And so I'm thinking to myself, okay, if I put that into v naught on the right side, what's going to happen? I don't know. I have sine over cosine with its tangent. That's pretty easy. Let's go ahead and let's solve for t and see what that looks like and kind of work that out there and see which one's going to be easier. So both will work. Both will work. And you won't get stuck one way or the other. But one is usually a lot easier than the other. I look at that and I go, t, I got to put it in two places. Not a big deal. T squared here, so I'm going to square this entire thing. So that makes it a little bit more complicated. And then I got a variable that I don't know in the denominator that's squared. And then I put it in over here as well, but I don't have to square it, which is nice. I have v naught in the denominator then, so the v naughts are going to cancel out here. So, I don't know, 6 in one and half dozen in the other. It's an old expression because, half dozen is 6. The expression means it doesn't matter which way you do it. 6 in one, half dozen in the other, you get the exact same thing. So, what am I going to do? I'll go ahead and I'll use the v naught and I'll plug that in there. It's really just about the exact same thing, so it doesn't really matter. But if this was live, I would ask you what you want me to do, and then you probably would sit there going, I don't know, it doesn't matter to me, just do one way, what are you doing? And then I would just choose one way. Anyway, so I just chose one way. Times the sine of 30 degrees, don't forget about that, because like this first bit there is just v naught, and then multiplied by t. Now, I have t in the denominator there, but notice it's going to cancel out with itself because the cosine and sine, that simplifies down to just tangent of 30 degrees. Cool. The t in the denominator, t in the numerator, those cancel out there as well. And so now I just need to clean things up here and do a little algebra. It's just algebra. -4. So, yeah, the real question is this question actually harder than the other ones? And I would say no. No, actually, it just has more algebra. That's it. Is the physics harder? No. You'll notice the physics is exactly the same as every other problem. So physics is not harder here, but the math is, I'd say, a little bit more challenging. So then I got a second-degree polynomial, but I only have one term that's got a variable in it, so this is actually pretty easy. You can do this without even using that solver on your calculator. I'm going to go ahead and I'm going to move. Actually, what I'm going to do is I'm going to take the -4.9 t squared. I'm going to move it to the other side so it makes it positive because we want that positive anyways, and I'm running out of room on the left-hand side there. So 4.9 t squared, I'll move the -4 over to the other side there as well. So I have 31 tangent of 30 degrees, whatever that is, just a number, plus 4. And so then you remember, this is just a number there. There's no variables there. It's just a number, right? So I'm going to divide both sides by 4.9 and square root it at the same time. I think you can handle that. So now I'm going to have t is equal to, well, it's this whole stuff that's right there times the tangent of 30 plus 4, and then I just divide that by 4.9. And so then that's just a number there under there. And I grab my calculator and I go and do that. Look, I didn't need the equation solver. I didn't need quadratic formula, nothing like that. So then I just punch it in there. Make sure you got parentheses around everything that needs to have parentheses. Make sure you're in degrees when you need to be in degrees. So that numerator needs to be in parentheses there, divided by 4.9, and my parentheses. And I get a time of 2.11 seconds. So that's the time. But did I want to know that? No, I didn't, but I sure can go find the velocity now. Chung, 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 chung. So I go and I plug that into the velocity there. Let me get rid of this so then I can actually go and do that. So sorry, I plug that t into the time, into the original velocity equation. And then I just solve it. That's it. So then it's all just numbers after that. So I'm going to store that previous number as v, because why not? You can store that as anything you want in your calculator. And then I do 31 divided by, now I have that number, 2.11. I have it in as v, so I put it in as v times the cosine of 30 degrees. And I get 16.93 meters per second. Boom, that's it. Boom! Now look at that. Look at that. That's not too bad. That's not too bad. And let's do a little recap here, because this went pretty fast. A little recap. The original problem here, when I was drawing it out, and comparing this to number 3 especially, you go, that's pretty much the exact same thing. The only thing that was a little bit odd is that my component vectors were in terms of this variable v0, but nothing harder there. Okay. Then I go over to my equations here, and it was all right as rain. Look at this first line was the same thing as before. And the second line, a little bit odd, you might say, because I have this variable v0 here, and I have t. But it's two variables, just like in problem 3. Those two variables that was there as well. So no harder yet. Now let's keep going on, because what did I do next? Next I went over to the vertical bit, and then I plugged things in there. And now this looked a little odd, and it, maybe is slightly harder, because I have now two variables in here, and I couldn't solve this straight away. And on the other ones I could solve it straight away. So, up until, so basically, and the physics is done after that. So like right here, I'm going to draw a line. This line right here. Once you got to that line, you did all the physics. The physics is done. That's the physics is done line. Great. So if you got up to that green line, you've done 100% of the physics, basically. And then after that, this is all just math. That's all just math. So if you had a problem with that, you had a problem with math, and that's that you need to, you can overcome that, and that is a good and important thing. Math is a tool that we use to be able to figure out all of this stuff. And then we, assigned some meaning at the end there. We kept the real variables, and we know that that's the original velocity now. And I guess that's a little bit of physics, and we put units on it, so I guess a little bit of physics. Actually, the units is math too. Most textbooks don't. They kind of leave them out there. Some textbooks don't, though. Some textbooks put in like a generic unit. Some math textbooks put in a generic unit all the time as like a lower script U is usually what I see. But anyways, that's it. I hope you have a wonderful day. Toodles.